Good to go? All right, we're going to go ahead and get started. My name is Gabriel Cardona, and I'm a developer evangelist from Avalanche. We're going to be giving a demo on how to launch an Avalanche subnet on your local machine. It'll be a 5-node validator. It'll be a 5-node network. We're going to show how to deploy a custom virtual machine, how to deploy a smart contract, and then how to interact with that smart contract. Before we do that, I'm going to give a brief introduction to exactly what Avalanche is. We're going to talk about some of the unique attributes of Avalanche, such as Avalanche consensus, Avalanche as a network of networks. We're going to talk about what exactly subnets are, and then we're going to dig into virtual machines as well. So Avalanche is a global financial network for the issuing and trading of all digital goods, and we enable potentially millions of validators to process thousands of transactions per second with near instant finality, and we do that using a protocol which is completely green and quiescent. And we have paired this very high throughput, very fast finality protocol with an architecture which can meet the needs of unique financial and decentralized applications. And we accomplish this through the notion of subnets or subnetworks. So subnets allow anyone anywhere to spin up a tailor-made network with custom virtual machines and complex validator rule sets. And so the way to envision Avalanche is like a network of networks. We're a platform of platforms, and we envision thousands and thousands of these public and private subnets to all emerge into this global marketplace, which we call the Internet of Finance. And so before I dig into what makes Avalanche special, I just want to give a brief history on the evolution of the blockchain revolution. I suspect everybody in this room, this isn't going to be a lot of news to you, but it helps to kind of appreciate where you're going if you can appreciate where you're coming from. So very quickly, let's kind of go over, as we see it at Avalanche, the evolution of the blockchain revolution. So of course, blockchain 1.0 we think of as Bitcoin, right? In the beginning was Bitcoin, and Bitcoin was good. And Bitcoin really proved to the world there was a need for this robust and decentralized payment network. But as big of a leap forward as Bitcoin was, obviously it still has its downsides. So Bitcoin is very slow. It has low throughput. It only does a handful of transactions per second. It doesn't have fast finality. So it takes around an hour before you can be confident that your transaction is not going to be reorged out from under you. Obviously, I'm aware of other networks such as the Lightning Network, but I'm referring to the Layer 1 Bitcoin network for the sake of this particular presentation. Bitcoin is not lightweight and green. I'm sure you've seen the memes go around that Bitcoin consumes more energy every day than some nation states. And Bitcoin has a scripting language called Script, but it's very, very cumbersome and awkward to use. It's stack-based, and it just doesn't feel very modern if you've come of age in the era of TypeScript or Python or Golang or Rust, etc. And then another big downside to Bitcoin is that it doesn't have native tokens. So of course there is an opcode called opreturn that allows you to write 80 bytes of arbitrary data to the blockchain, and you can encode token issuing and transmitting and minting and burning transactions into this 80 bytes. And you can create wallets which tease out that 80 bytes and then basically make sense of the data, but it's really just a hack. It's not native miner validated tokens. So as great as Bitcoin is, and obviously it's had a huge impact on everybody's life, mine included, it leaves a lot of things to be desired and inspired engineers to do better. So we think of blockchain 2.0 as Ethereum. And of course, Ethereum is, as we see it, a decentralized application which enables developers to launch their own decentralized applications on top of it in the form of smart contracts. And prior to Ethereum, if you wanted to launch your own decentralized application, you really had to roll your own decentralized network. And so this led to a very bespoke environment where few projects were able to reach the network effects required to tip and go mainstream. So by enabling developers to launch their own smart contracts on top of it, Ethereum led to a huge network effect around tokenomics, initial coin offerings, obviously NFTs, DeFi, yield farming, prediction markets, distributed autonomous organizations, and so much more. We think of Avalanche as blockchain 3.0 technology, and similar to Bitcoin and Ethereum, we're introducing a handful of new paradigms that I want to go over today. So we're going to talk about Avalanche consensus being sort of the third major paradigm shift in the field of consensus. We want to talk about Avalanche being a network of networks instead of being one virtual machine and one set of validators or miners. We want to talk about virtual machines, what they are and how they fit into our network. And then lastly, we want to talk about subnets and how they enable developers to spin up their own tailor-made networks. So first, Avalanche consensus. What is consensus? If you work in this industry, I'm sure you hear the word consensus a dozen times a day. What exactly is it? Consensus simply means how do you get a series of individuals, or in our case, machines, to come to an agreement on a decision. And so it's that simple. How do you get a bunch of machines to agree on something? And it's a very, very rich field of computer science. It goes back around 40 years. And we think of Avalanche being the third major paradigm in the field of consensus. So here you can see the first paradigm was called classical consensus. It goes back to the 70s and the 80s. And classical consensus has low latency. It has extremely high throughput. It's lightweight. It's green. But it's not decentralized, it's not robust, and it performs very poorly in adversarial conditions. In 2008, 2009, when Satoshi introduced the world to Bitcoin, the world got turned on to what ultimately became known as Nakamoto consensus. The Nakamoto consensus is very decentralized and scalable and robust, but as I mentioned before, it doesn't have high throughput, only a handful of transactions per second. It doesn't have great latency or finality. It takes about an hour to be confident that your transaction is not going to be double spent or reorged out from under you. It's not very green or lightweight. As I mentioned, there's a meme that goes around that Bitcoin burns more energy every day than a lot of nation states. And it performs okay in adversarial conditions up to the famous 51% attack. In 2018, a pseudonymous group known as Team Rocket released a white paper on the IPFS describing the third major paradigm in the field of consensus, what is now known as Avalanche consensus. And Avalanche consensus is really the perfect storm of classical and Nakamoto consensus. So it's very scalable, it's very robust and decentralized. I think there are currently around between 1,200 or 1,300 full block and vertex producing validators on the Avalanche mainnet. The protocol in theory enables millions of validators, so it's very, very decentralized. Avalanche consensus is low latency, so we have sub-second immutable and irreversible finality. So there is no notion of a reorg on Avalanche. Perhaps you heard recently that Polygon had a reorg, and it's happened on other networks as well. That concept does not exist on Avalanche. So in less than 1 second, your transaction is immutably and irreversibly finalized on the blockchain for all time, which is really, really powerful for DeFi in particular. It has extremely high throughput. So our X chain has 4,500 transactions per second. Just about last week, maybe 2 weeks ago, we released Hyper SDK, which is a Rust SDK, and we're working on a corresponding TypeScript as well as a corresponding, it's a Golang SDK we're working on for Rust and for TypeScript. The Hyper SDK's sample SDK that we shipped with it has over 10,000 transactions per second, so we have extremely high throughput. It's very lightweight and green. It can be run on a PC. It can be run on a MacBook. You can run Avalanche on a VPS droplet out on the cloud. In the future, you'll be able to run it on Internet Things of devices, such as the Raspberry Pi. And Avalanche consensus is parameterizable, so it performs very, very well in adversarial conditions. I had this really great demo for you to kind of show you exactly how Avalanche works, but unfortunately they told me it wasn't working in the back. I still kind of want to talk through it a little bit, and then if you want to see it later, I can show it to you on my laptop. But technically, Avalanche is a metastable consensus protocol inspired by epidemic protocols and gossip networks. Excuse me. The process used to determine whether a transaction is preferred or not is referred to as repeated random subsampling. And this demo was created by our chief protocol officer, Ted Yin. So Ted actually was one of the creators behind Hot Stuff. Hot Stuff is the classical consensus protocol, which is behind Facebook's Libra or DM network. He's now at Avalanche, or at Ava Labs, working on Avalanche consensus. And in this demo, at a super high level, what you would see is all of these different nodes, or all of these squares in this grid represent a different node. And the color, whether it's blue or orange, represents its proposal. And Avalanche consensus can handle non-binary decisions, so you can handle it 5 different options and it'll still reach, immutable and irreversible consensus. But for the sake of most financial transactions, they're usually binary in nature. Is this transaction, accepted or is it rejected? The darkness of each node represents the node's convictions. So it really, really thinks this transaction is blue, or it really, really thinks this transaction is orange. And when you see it, each one of the nodes will begin to repeatedly and randomly sample their peers, and they will change their own color and their own depth of conviction based on what their peers say. And it only takes a couple rounds of sampling, as you can see at the bottom, and the whole set will tip an Avalanche into consensus. It's really cool to watch. It's very elegant, and it helps you kind of develop an intuition around how Avalanche consensus works. Again, as I mentioned, I'm happy to show this afterwards if anybody wants to see it, or I can share the website so you can actually play around with it yourself. The next big paradigm shift in Avalanche is that Avalanche is a network of networks. So as I mentioned, Avalanche is different than traditional crypto networks such as Ethereum and Bitcoin that have one virtual machine and one set of validators or one set of miners. Avalanche is a network of networks, and there are compound network effects. And to help visualize this, I have a really great slide. So shout out to the amazing CryptoSec. You can see the Twitter handle at the bottom. Please go check out this person on Twitter and Medium. They have absolutely incredibly insightful posts on all blockchain networks, not just Avalanche, but I took this from one of their Medium posts. So here you can see that the gray oval represents the Avalanche network, and inside it are all of the different subnets which are live on Avalanche. They're represented by the different circles. And in each one of those are green squares which represent different virtual machines or blockchains which are live on those subnets. And then you can see lines in between the different subnets which represent the ability to move assets and users between the different subnets. And then at the top you can see other networks, Ethereum and Bitcoin. We don't yet have a bridge to Cosmos, but we do have a bridge to Ethereum and Bitcoin. So since this is the interoperability summit, I wanted to point out that bridge.avox.network, which is bundled with our Core wallet. So Core is our competitor to MetaMask. We have a mobile version, we have a browser version, and we have a Chrome extension, obviously. Since our bridge was launched about a year ago, over $500 million in assets have been bridged between Ethereum and Avalanche. And when I checked about a week and a half ago, there's BTC.B, which is a wrapped version of Bitcoin on the Avalanche network. More Bitcoin.B had been bridged between Bitcoin and Avalanche than is currently live on the Lightning Network. There was about $120 million when I checked last week. I don't know what it is today. And I also want to point out with regards to the lines between the subnets, we recently launched what's known as Avalanche Warp Messaging. So this is our new native subnet to subnet messaging protocol, and it has the ability for existing cross-blockchain networking messaging protocols such as Cosmos's IBC or Polkadot's XMC to be overlaid on top of Avalanche Warp Messaging. So again, in the context of this being the Interop Summit, we're absolutely huge advocates of interoperability. We believe that the blockchain has the potential to be as transformative as the web. In the same way the web democratized information and made it ubiquitous, the blockchain has the potential to do this for money and finance and privacy and so much more. And we believe that interoperability is absolutely critical for the blockchain to be as transformative as the web. So we're huge advocates of interoperability. Next, I want to talk about virtual machines. So a virtual machine defines the application level logic of your blockchain. Technically speaking, a virtual machine is a state machine. So it defines a blockchain state, a state transition function, transactions, and an API through which users can interact with your blockchain. And every single blockchain which is live on the Avalanche network is an instance of a virtual machine. So the way to really think about it is like a virtual machine is like a class in object-oriented programming. So a class is a description of an object, it's a template, and from that template you can instantiate as many different instances of an object as you wish. And all of these objects, though they were derived from one common template, they're all unique entities and they all have their own separate state. A virtual machine is very much like a class. It is a description of a blockchain. It's a description of the application level logic of your blockchain. And from this virtual machine, you can instantiate as many different blockchains as you wish. And each one of these blockchains, even though they were derived from a common virtual machine, a common template, they're all their own separate entities. They all have their own state. And as a developer, when you write your virtual machine on Avalanche, you don't need to concern yourself with any lower level logic like networking. You don't have to worry about consensus. You don't have to worry about the structure of your blockchain. All of that is provided for you by Avalanche behind the scenes. All you need to do is focus on the special sauce that makes your blockchain unique. And finally, before I show my demo, I want to talk about subnets because they're very, very important in the context of Avalanche. So a subnet is a dynamic set of validators working together to achieve consensus on the state of a set of blockchains. And each blockchain is validated by exactly one subnet, and one subnet can validate many different blockchains. So a subnet can have more than one blockchain. A perfect example is our primary subnet, which went live whenever we went live in August 2020. it has three virtual machines or three blockchains: the X chain, the P chain, and the C chain. And a node can validate many different subnets. So if you think about if you kind of visualize the heterogeneous nature of the blockchain, you have a node which can validate many different subnets, a subnet which validates many different blockchains, and a blockchain which is an instance of a virtual machine which can be validated on many different subnets. And subnets can kind of have a spectrum of public to private. And subnets have a lot of cool features. So they manage their own membership, and they can require that constituent validators have certain properties, and that's very useful. So for example, Avalanche's subnet architecture makes regulatory compliance completely manageable. A subnet can require that validators meet certain requirements. So for example, you can say, all the validators in my subnet need to be located in a certain legal jurisdiction or a certain country. All of the validators in my subnet need to meet certain KYC AML requirements. All of the validators in my subnet have to hold a certain license. All of the validators in my subnet need to meet certain hardware requirements, et cetera, et cetera. There's also support for private blockchains. So you can create a subnet where only certain predefined validators can join, and you can create a private subnet where the contents of the blockchains are only visible to those validators which you whitelist to be part of the subnet. And this is ideal for organizations that want to keep their information private. There's also separation of concerns. So in a very rich and heterogeneous network like Avalanche, some validators will not want to validate certain blockchains simply because they have no interest in those blockchains. And so the subnet model allows validators to only concern themselves with blockchains that they actually care about, and this reduces the burden on validators. There's also application-specific requirements. So different blockchain-based applications can require validators to meet certain hardware requirements. So for example, imagine you have an app and it requires lots of RAM or lots of CPU. A subnet can require that validators meet certain hardware requirements so that the application never suffers from low performance or slow validators. And before I show my demo, just to give you a sense of what a subnet looks like, this is our primary subnet. This is what went live in August of 2020 when we went live. And as I mentioned, it has three chains on it. We have the P chain, the X chain, and the C chain. A couple other things to realize is that we have different data structures. So we have linear blockchains, and then we have DAGs, directed acyclic graphs, and of course they solve different problems. And then we also have account-based systems like Ethereum, and we have UTXO-based systems like Bitcoin, and you can mix and match those. So for example, in the middle we have the Avalanche X chain. That's an instance of the Avalanche virtual machine. So the virtual machine is the Avalanche virtual machine. The instance of it is the X chain. It's a DAG, it's a directed acyclic graph. It's very good for peer-to-peer payments and simple token transfers. It's where you can create assets. We call them Avalanche native assets. For example, AVAX, the native asset of Avalanche, is a fixed cap asset. It was issued on the X chain. There will only ever be 720 million AVAX. We have the C chain, which is actually an instance. Oh yeah, the X chain is a UTXO, so it's a DAG with UTXO. The C chain stands for smart contract chain. It's an instance of the EVM, so it's a linear blockchain. It has accounts. It has 100% backwards compatibility with other existing EVM developer tooling. So if you use Remix, Hardhat, Truffle, etc., you can just change the network ID, deploy your smart contracts to this chain, and it will work out of the box with no other configuration. There's also the P chain, which is a linear chain, but it's UTXO. So we have a DAG with UTXO, we have a linear chain with accounts, and we have a linear chain with UTXO. The P chain is like our administration chain. It's where you can add validators, add delegators, launch instances of subnets, etc. And then you can see the red line that shows you can swap assets between them using either subnet to subnet asset transfer or virtual machine to virtual machine asset transfer. We actually have both available. And so now I want to show you a demo. I actually recorded my demo. Hopefully it shows up. Yeah, I wasn't quite sure of how this was going to work, so I made the recording. Hopefully this works.
Now it's time for the demo.
Hopefully you can hear it. Can you guys hear it?
How to spin up a local subnet with 5 validator nodes. We'll also launch a custom VM called the Subnet EVM. Subnet EVM implements the Ethereum virtual machine and supports Solidity smart contracts, as well as most other Ethereum client functionality. And in the spirit of interoperability, since this is the Interop Summit, you can take any smart contracts which are live on any EVM chain, so Ethereum, Binance, Polygon, etc., change the network ID and deploy them to an instance of the Subnet EVM, which is running on your custom subnet and everything will work out of the box. Subnet EVM has 100% backwards compatibility with existing EVM developer tooling and workflow. So you could then use Avalanche's warp messaging protocol to move assets between subnets on Avalanche, or you can use technologies such as chain bridge or other bridging tech to bridge your assets to other instances of the EVM. We are big advocates of interoperability and believe that it's absolutely critical in order for the blockchain to reach its potential and be as transformative as the web and beyond. So here we'll be launching a local subnet with a custom virtual machine, and we're going to be using Avalanche CLI. And Avalanche CLI is a command line tool which gives developers access to all things Avalanche, specifically helping devs build and test subnets. So you can see here that there are really 4 major commands in Avalanche CLI. First is key, and it lets you create and manage testnet signing keys. Next, we have network, which lets you manage locally deployed subnets. And we're going to check that out in a minute. We have the subnet command, which lets you create and deploy subnets. And then lastly, we have the transaction command, which lets you sign and execute specific transactions. Avalanche network lets you start and stop a local network. Also, you can check its status. So Avalanche. You can also check its status, which we'll do shortly, and you can clean it up, which stops a running network and deletes its state. The subnet command lets you create and deploy a new subnet. It also describes a network, and it will list all subnets or all subnets which you created. And then you can also import and export subnet settings, and you can add validators or have your validator join a network. So first, we want to run the Avalanche subnet create command. And we're going to create a new subnet called ETH Denver subnet 1. And so by default, you can choose between subnet EVM, spaces VM, which is an authenticated hierarchical key value store, or a custom VM. And we're going to go with subnet EVM. Next, you need to enter a chain ID, which can be any positive integer. If you were launching this subnet to production, you would want to go to chainlist.org and make sure that you're not choosing the chain ID, which is already in use by another network. But since this is only on localhost, the chain ID doesn't matter. So we're going to go with 1337. Next, select a symbol for your subnet's token. We're going to go with test, since this is a testnet subnet. And then next, which version of subnet EVM do you want to use? We're going to go with the latest and the greatest. So now, how would you like to set fees? We recommend using low disk use and low throughput. And next, how would you like to distribute your funds? Here you can actually airdrop some of these native test tokens for your subnet to any address that you wish. By default, we have an address which we call the EWOC address, EWOQ, because EWOQ are the first 4 characters of the CB58 encoded private string. I'm going to go with that here, which is the first option. But if you were going to launch this to a production, you would not want to choose that option, since we have the EWOC private key in a lot of our technical documentation, and many developers out there use it. So you wouldn't want to, of course, airdrop production tokens to that, because everybody has access to that private key. You would instead choose customize your airdrop and airdrop the tokens to an address which you control. But here we're going to airdrop 1 million tokens to the default address. You can see it says do not use in production. And then next it says, would you like to add a custom precompile? So you can actually extend the functionality of subnet EVM by a stateful precompiled contracts. We have precompiles for restricting who can deploy a contract, for restricting who can submit transactions, for minting native coins, for configuring dynamic fees, and for changing the reward mechanism, none of which we're going to leverage in this demo. So we just choose no. And boom, you can see we successfully created a subnet configuration. So now if we say Avalanche subnet list, it will list our ETH Denver subnet 1. And then we can call describe ETH Denver subnet 1 and see a nice description of the details, the gas config, the airdrop, and then any precompiles. In this particular case, there were none. We can then also call that with the -- Genesis or -G flag, and it will give us that same output, but as a nice JSON object. And you can actually use this JSON whenever you're configuring your validator. You can actually use this exact JSON data structure you see here when you're configuring. Okay, so now what we want to do is we want to deploy this. So Avalanche subnet deploy ETH Denver subnet 1. And we're going to be deploying to our local network, and we're going to be paying the fees with the local EWOC key. You can use a hardware ledger wallet, which is what would be used to deploy to Fuji or mainnet, but we're not going to be doing that for this demo, so we don't need the hardware wallet. So here you can see it's deploying it to a local network. Okay, so it's been deployed. Now we're waiting for the network to acknowledge. And so boom, now we have a 5-node validating network running with this subnet and subnet EVM deployed. Here you can see it lists all 5 nodes and the RPC URL for each one of them. And then down here, it gives us a little bit of information which we're going to be using to plug into Core Wallet. It would also work with MetaMask. You can also say Avalanche network status. And it will show us again, we have 5 different nodes validating. It gives us the number of nodes, the number of custom VMs, and that it's healthy, et cetera, et cetera. So now what we want to do is we want to take this information and we're going to be plugging it into Core. So for that, I jump over to Chrome and I'm going to the Core extension. Up here we have networks. We want to add a new network. So we get the RPC URL. The network name, the chain ID, and then the token symbol, which was test. You can also add a token name, Explorer URL, or a logo URL, all of which are optional and none of which we need for this demo. And now we hit save. And it's adding them to Core. You can see this says custom network added. And then right here, we can actually choose it. And so you can see here, it gives us the private key in hex encoded format for what we call the EWOC key. So I mentioned EWOC are the first 4 characters of the CB58 encoded version, but here it is encoded as hex. You can import this key into either MetaMask or Core, and it will give you this address. I've already imported it into this, so you can see at the top, the address is 8BD. And so here you can see 8BD, and it ends with 52FC. So I have already imported this private key into Core. Again, you can import this into Core or MetaMask, and you can see that I'm on the ETH Denver subnet, and it has 1 million test tokens, which if you remember, I airdropped to the EWOC address. So far, so good. So now what we want to do is we actually want to jump on over to Remix, and we're going to deploy a very simple smart contract and interact with it. So there is a storage contract which ships with Remix. You can see it over here in the list of contracts. And basically what it does, it's very simple. It allows you to write a number to the blockchain and read from the blockchain. So I just want to make sure and jump on over here and make sure it's compiled. And then I want to come on over here and you can see the injected provider. It says MetaMask, but it's actually Core. You can see the custom network ID is 1337. So that shows us that we are connected to the right network, and it shows the right account. So this is the EWOC account. If you remember, it starts with 8BD and it says 1 million ETH, but it's actually the test tokens. So now what I want to do is I just want to deploy this. You can see down here, there are no deployed contracts. So now I want to deploy this. It's going to pop open this Core pop-up. You can see the account is the imported account 1. That's the EWOC account. The network is ETH Denver subnet 1. So we're on this subnet. And then down here, we set the network fee. I'm going to hit approve. And so now you can see it has deployed this smart contract down at this address. So if I open this and I hit retrieve, it's reading from the blockchain and it's giving us the value 0 because we've not yet written anything to the blockchain. So now if we write a custom number like 507 to the blockchain, of course, it's going to give us this pop-up because we need to pay for the transaction to write to the blockchain. So we're going to approve. And so that's done. And so now when we go to retrieve, it gives us the value 507. So this showed that we were able to use Avalanche CLI to create a 5-node validating network. We then created a custom virtual machine using, in our case, the Subnet EVM, which has 100% backwards compatibility with existing EVM dev and tooling for interoperability. We then were able to configure it with an airdrop if we wanted to add precompiles and the gas config, etc. We then fired up the 5-node network. We got the values for an RPC endpoint. We added them to the core wallet. We then were able to import the EWAC key and show that it got the million test tokens that we airdropped to it. We then went to Remix and ran the most basic storage read and write contract. We compiled it. We then deployed it to the Subnet EVM and we're able to read and write from it. So that shows the demo that I wanted to show you. Again, for interoperability's sake, any smart contract which is live on any Ethereum or Polygon or Binance, any EVM chain, you can take and you can just add a new network ID and potentially change the gas config, deploy it to either the Avalanche C chain or an instance of the Subnet EVM, and it will work out of the box. We're huge advocates of interoperability, and we think it's absolutely critical for the blockchain to fulfill its potential and be as transformative as the web and beyond.
Okay, so thank you. My name is Gabriel Cardona. You can reach out to me on Twitter if you want. You can drop me an email. We're also having a Avalanche meetup on Friday. If you guys are interested, let me know and I can give you the details on that. My time is pretty much up. I can take a question or two if you guys have any, or you can come and connect with me afterwards.
Hi, Gabriel. I saw the announcement on the hyperscale, and I was wondering if you could talk more about the IoT use cases and how this would work with an Avalanche subnet. Would it be that the actual nodes or a full node would run on the IoT device, or would it be like light clients? I'm just curious more on that use case.
Yeah, so whenever we launched Avalanche Go back in August of 2020, you could actually run it on IoT devices. So it used to run on our Raspberry Pi. I actually created the documentation for that in the very beginning. Since then, the software has actually grown, as you might imagine, over the past 2.5 years, and it no longer runs on a Raspberry Pi, but the intention is for it to be able to do that in the future. What we're hoping is we have a Rust SDK, and we have a couple sample SDKs for that as well, and we imagine that the virtual machines will be written probably in Rust, potentially in Go, but more likely in Rust. And yeah, we imagine that the IoT devices will run the virtual machine and that they'll do full Avalanche consensus, because as we mentioned, Avalanche consensus can potentially support millions of validators, and it's our intention to see Avalanche run on the Internet of Things, Avalanche to run on mobile devices, PCs, laptops, iPads, everything. So yeah, our intention is for IoT devices to run a virtual machine, probably written in Rust, and to do full Avalanche consensus.
Got it. Thank you very much.
Thanks, man. There's one in the back as well.
Hello. So I guess two related questions. The first one is, if I want to deploy a subnet on mainnet, let's say blockchain, and deploy it, you show local testing, that's great. If you want to actually deploy a new subnet on production, how much does that cost? Is it monthly cost? How is it that paid? And the second one is writing custom virtual machines. So
what was the second one?
Custom virtual machines. You talk about Rust SDK.
Yeah.
So like, let's say, okay, build my own blockchain Rust, and they want to deploy it on Avalanche's own subnet. What would that process look like? And yeah, how much does that cost to run these things?
Yeah, so the primary cost, the main barrier to entry is going to be every single node has to be a full validating node, which means you have to stake 2,000 AVAX. And of course, 2,000 AVAX is a non-trivial barrier to entry. That's a lot of USD. We appreciate that. It's definitely on our roadmap to lower that in the future. That's going to be one of the first things that's available once the governance goes live on the Avalanche network. But for today, the primary barrier to entry is simply going to be staking 2,000 AVAX. We recommend a minimum of 5 validating nodes for each subnet. So you're already talking about 10,000 AVAX, which of course is a big barrier to entry, and we appreciate that. Other than that, the technical requirements of the hardware are actually relatively low. You can run them on like a medium-sized AWS node. In fact, we have a one-click validator node you can launch on AWS. I believe it's a couple $100s a month to run the node. So it's not incredibly cheap, but the barrier to entry is definitely staking the AVAX and not paying for, the online resources. And with regards to launching a custom virtual machine, so yeah, as I mentioned, we have a Rust SDK, we have a Golang SDK, we have a TypeScript SDK called Avalanche JS, which I used to maintain. It was downloaded about 250,000 times in 2022. So the first thing is you compile your SDK and you put it in the plugins directory of Avalanche Go. Then you need to have the other validators also run it as well. And there's two different ways you can launch a subnet. You can have permission subnets or permissionless subnets. On the permission side, as the person who launches the subnets, you actually have to whitelist all of the different validators and add them. You can do that using Avalanche CLI, and then they actually have to also add the subnet. We did this because we wanted to prevent people from just adding random validators to their subnet. Obviously, that wouldn't be a good developer user experience. And there's also what we call elastic subnets. So these are permissionless subnets, and basically you allow anybody who wants to join your subnet to join them, and it's a completely permissionless process. They just need to run your virtual machine, compile it, put it in their plugin directory, currently on Avalanche Go, their full node, and then they need to add your subnet to their virtual machine, again, using Avalanche CLI. As I mentioned in the demo, Avalanche CLI supports ledger hardware wallets. So if you're deploying to Fuji or mainnet, we suggest doing it over a hardware wallet instead of storing like local keys on your machine.
So I don't understand. I need to stake for 2,000 AVAX for different nodes, but that means I'm running those validators or other people running those validators?
If you stake the 2,000, you're running them. If you can get access to other people who are already running validators, you don't have to do it. There are a couple of projects in the works right now that are trying, that's the biggest barrier to entry right now, is staking 2,000 AVAX and or finding 5 validators. So there are a lot of validator as a service kind of apps that are in the works right now. We haven't announced them yet, but that's definitely something that's on the roadmap because we want to make it a lot easier for people to find the validators and not have to stake 10,000 AVAX. So, yeah.
Thank you.
Is that it?
Hey, just wonder what's the overhead for the main Avalanche chain for add subnet?
I didn't hear you, I'm sorry.
What's the overhead for add a subnet to the mainnet Avalanche validators?
So you're talking about like the hardware requirements?
No, I mean, kind of like assume I'm a validator and how many subnet can run and how much resources for one subnet.
So yeah, that definitely depends on what the subnet is doing. As I mentioned, that's one of the really great things about subnets is that you can sort of have these application-specific blockchains, and then you can have this separation of responsibilities. And so if somebody is running like a super high-end subnet that's doing like global payments or something like that, and you don't want to validate it, you don't have to. But currently, pretty much everything that's running, we have a we have a virtual machine called Subnet EVM. That's what I demoed here. It's basically has 100% backwards compatibility with existing Ethereum developer tooling. And right now, as I mentioned, you can pretty much run like a medium-sized AWS instance. And I think we have maybe 10 subnets that are live on our primary subnet, on our mainnet. And more than that, I don't know what the total count is on our testnet right now. But we've never run into anybody who's not been able to validate all of them. So if it's just doing like Solidity smart contracts, you can pretty much do them all. We're waiting for somebody to come in and introduce a subnet which is doing something like a lot more computationally intensive, and then that answer might be a little different. All right, thank you, everybody.